So going through some examples then.
Good.
So if you look at the worksheet, question 1 essentially looks like this. Right? You've got a battery like so.
Yeah.
And you've got a circuit like this. They've used a squiggly line to represent a resistor. I've used a box. Just different convention, but same thing. You are told that this is I1 here. You are told this is I2 here.
Yeah.
You are told this is 3 amps. You are told that this is 6 ohms. And you are told this is 12 ohms. And you want to find the unknown quantities of each thing. All right, so P, okay, so they want you to find the power. So to be perfectly clear, the formulas you need to know, apart from the ones we talked about with circuits already, for each individual component, you've got V equals IR and P equals VI. And so this question, I'm going to call this A and B. This question is basically saying, apart from working out I1, I2, they also asking you, what is the power
Yeah.
of component A? All right, and you know the voltage, we need to work out the voltage as well. Okay, so we need to look at this and know exactly what it is we know. So if you look at this, you will notice hopefully that we don't know the voltage of the circuit, right?
Yeah.
We don't know the voltage of the circuit. We don't know the current of the circuit. And we don't know well, actually, we do know the resistance of the circuit. So that's one way we could approach it first. So we don't know the voltage of the circuit. We don't know the current of the circuit, but we could work out, given that we know both the resistance of these, the resistance of the circuit, and then from there, you know, start working things out a little. All right. So
Yeah.
that's one thing we could work out. But also, let's look at A by itself. We don't know the voltage across A because it's the voltage across, you know, the battery, and we don't know that. We don't know the current, we just know the resistance. So that doesn't really help us too much. Okay.
Yeah.
Now for B though, we don't know the voltage across B because we're not given it, so to speak. But we know the resistance and we know the current, right?
Yeah.
So can we work out the voltage?
Yeah.
Right. And that's probably the most important part of this question, right? So V equals IR. All of this is for B. We note that for B in particular, we're talking about for B in particular, the current is 3 and the resistance is 6, giving you 18 volts across B.
Yeah.
But the thing is this, right? Once you know it's 18 volts across B, what is the voltage that the battery gave to B?
The battery give two.
If B, I mean, is this series or parallel?
Parallel.
So if B has 18 volts, what's the voltage of the battery?
Um, it shouldn't be 18.
It will just be 18 as well because the voltage just came directly to
Oh,
B.
yeah.
So therefore, we already know the voltage of the circuit. This is 18 volts. And what's the voltage across A?
Uh, so it's also 18.
Yeah, because it's parallel. Remember, parallel, all the voltages
Parallel.
are the same.
Oh, okay. So how about for series, the voltages?
Well, then it's the sum, right? So it depends on what the circuit is. But this is a parallel circuit. So once we know that's 18, then this has to be 18.
Yeah.
And do we know the resistance of A?
Yes, 12.
So what's the current in A?
12 volts.
What's the current in A?
So the current is 3/2.
Yep, 1.5 amps. So in other words, the I2 is 1.5. We've already got that. right? So that's I2.
Yeah.
I2 is basically current through A. And then we can also work out the power of A. So it's just 18 times 1.5, which is 27 watts. Does that make sense?
Yeah.
So we've worked out the P, we've worked out I2, and then when we need to work out I1, well, I mean, we've got the V, we've got the I and the R of B, we've got the V, the I, and the R of A. To get I1, it's just really the current of the circuit. We've got so many ways to do it now. We could either, so we could either do it as I1, which is the current of the circuit, equals IA plus IB, which we know is 1.5 plus 3, which is 4.5 amps, right?
Yeah.
And so we've already worked out everything they wanted us to work out, right?
Yeah.
But let's go further, right? So we've worked out the current, but we also know that the voltage is 18 volts, right?
Yeah.
So the resistance must equal 18 divided by 4.5, which will be 4 ohms. And the power of the circuit must equal V times I, so 4.5 times 18. Which will be 81 watts.
Why does I1 equal 1.5 plus 3?
Because that's 1.5 and that's 3.
Shouldn't it be like reciprocal?
No. When is the current ever the reciprocal?
Oh, that's resistor. Okay. Yeah.
So at this point in time, we've worked out the current by just looking at this and adding them together. We've worked out the voltage because already we, from here, that gives us the resistance. And we can also work out the power, which is 81 watts. We can also work out the power of B through many ways, but let's say, we could have 18 times 3, which is 54 watts. You'll notice, as it should, 54 plus 27 equals 81.
Yeah.
The sum of the power of the individual components is the total power in a parallel circuit. You'll notice that, 1.5 plus 3 equals 4.5. Yeah. And we'll also double check. We don't need to, but we've worked out the resistance already, but let's do it as if we didn't know the resistance is for. The other way to work out the resistance of the circuit is to do it as 1 over R of A plus 1 over R of B, which is 1 over 12 plus 1/3, which, if you like, is 1 over 12 plus 4 over 12, which is going to be 5 over 12. Oh, sorry, that's not 1 over 3, that's 1 over 6. That's why it's wrong, right? So you're going to get 1 over 12 plus 1 over 6, which will then be 1 over 12 plus 2 over 12, which is going to be 3 over 12, or a quarter. And so the resistance of the circuit is 4 ohms. Doing it both ways, you get 4 ohms.
Yeah.
Do you see what I mean?
Okay.
Now, you didn't need to do all of it for this question, right?
Yeah.
The question basically only asks you to find this part. It only asks you to find.
Actually, we need to, because the question says find the unknown quantities in each of the following circuits.
Yeah, but in question 1, they don't ask you for that. They only ask you for B, P at A, I1 and I2.
Okay.
Like, they didn't ask you to find P, I, and R for everything. I mean, we've done that, but they've only asked you to find the voltage of the battery, the current at I1, the current at I2, and the power of resistor A.
Yeah.
I mean, we've done literally everything.
Yeah.
Right? But all they wanted was, the ones I'm circling in yellow. Having said that, I do think that you should, try and do everything to make sure you, get all the practice you can get. But strictly following the question, we didn't need to do everything. We just needed the things in yellow: the I1, the I2, the PA, and the V.
Yeah.
Does that make sense?
Yeah.
Okay. So if we're looking at question 2 now, question 2 is, essentially one of the questions I gave you earlier with different numbers. So you can see that there's this part here, which is 3 ohms, and they want you to work out the power of that. And they've got 2 resistors here. This is 12 ohms. And this is 4 ohms. And they want you to work out the current going through both and the circuit. And you're told that this is 12 volts here. Do you feel like this is a question you can do by yourself now, given what we've gone through, especially with the earlier example of here? Or is this something that, it's basically exactly the same as this example, right? With different numbers.
Yes.
Nothing's really changed except the numbers. All right. You sound like you're still very confused.
Probably.
All right. So let's call these A, B, and C.
Yeah.
All right. And as before, it might help to recognize that you don't just have a series circuit. You don't just have a parallel circuit. So unlike question 1, where it's purely parallel, unlike question 3, which is purely parallel, you've got 2 here, which is both series and parallel, just like question 4. Okay?
Yeah.
And so as we said earlier, it may help to think of this as, to simplify this part that is parallel into one component, and we'll call this D, and basically think of it as you've got a 12-volt battery attached to A, and then it's attached to D, and this is now a series circuit.
Yeah.
So D just represents B and C altogether.
Yeah.
Now we know A has a resistance of 3 ohms. Now for D, let's work out the resistance of D. Remember, D is actually B and C in parallel, right?
Yeah.
So therefore you use the parallel circuit formula to do it. And we know the numbers here. So this will end up being 4/12 or a third. So after applying the parallel resistance formula to B and C, remember that just represents D. So that means that this is 3 ohms. Does that make sense?
Yeah.
And so now, if you look at the simplified sort of diagram here, conceptually, A and D are in series. So if you look at this circuit, then, the total, so if you look at the circuit in this way, then the resistance of the circuit is just the resistance of A plus the resistance of D because it's series. So it's just 3 plus 3, which is 6 ohms. Now the voltage of the circuit is given. It's 12 volts. So the current in the circuit is just V over R as always. So it's 12/6 or 2 amps.
Yeah.
So now we've worked out the voltage, the current, and the resistance of the circuit. So as far as this question is concerned, we've essentially already worked out the I1 because this question has an I1 here. So I1 basically is just asking what's the the current through the circuit, and that is just 2 amps.
Yep.
All right. So they also ask you for, we'll work everything out, all right?
Yeah.
They've also got I2 and I3 there, which basically means you want to work out the current going through each of them, and we'll do that shortly. But the point is, if we know it's 2 amps, then that means we know that the current through A is 2 amps and the current through D is 2 amps, right?
Yes.
So because I'm trying to reuse a bit of space so I can stay on this page, I'll just rewrite it here. So I now have worked out the current of A is 2 amps. But if I know the current of A is 2 amps, and I know its resistance is 3 ohms, then so remember I know the resistance is 3 ohms. So what's the voltage across A?
6.
Right, it's 2 times 3, which is 6 volts. Now, if A has a 6 volt drop, so it's 12 volts here and a 6 volt drop here, what's the voltage across D? 12 volts in total. You lost 6 volts here. Just left.
6 volts.
Right. So we know that D has a voltage of 6 volts. Does that make sense?
Yes.
But once we know D has a voltage of 6 volts, then it's quite easy, right? Because what's the voltage across B then?
Voltage across B is
These are in parallel.
Oh yeah.
So if D has a voltage of 6,
Also 6.
what's the voltage across C?
C. Oh yeah. So they're equal.
What's the resistance of B?
Resistance 4.
So what's the current across B?
1.5.
So we've already worked out I3. Similarly, what's the resistance across C?
It's 12.
So what's the current across C?
0.5.
And therefore, you can see, 1.5 plus 0.5 equals 2. It all makes sense as well.
Yeah.
So we've worked out the V, I, and R for A. We've worked out the V, I, and R for B. We've worked out the V, I, and R for C. We've worked out the V and R for A. So really, this particular question doesn't seem to ask for power. Oh, it does. It asks for the power of A. So anyway, we'll just work out the power for each and every one. All we need to do is take, we can use any of the power formulas, IR, VI or I squared R or V squared over R. They'll all give you the same answer. So because we know VI, I'll just take the power equals 12 watts. It's just 2 times 6. In the case of B, it's going to be 9 watts, 6 times 1.5. In the case of C, I'm going to take 6 times 0.5, so that's 3 watts. So you'll notice that this is 9 plus 3, which is 12 watts, plus 12 watts, which should give you 24 watts. And let's just double check here. The power equals 12 times 2, which is 24 watts, which makes sense as well. The total power of the circuit equals the power given off here, plus the power given off here, plus the power given off here.
Yeah.
Which is 12 plus 9 plus 3 equals 24. That makes sense. The current, it should equal this one, and it does. And it should equal those two added together, which it does. Can you see how everything is consistent?
Yes.
Yeah. Okay. Does that make sense? Yeah.
Okay, yeah, I got it. Yep.
Okay. So those are some examples of, you know, the
Yep.
sort of questions you might get. Did you want us to look through 3 and 4?
Okay, we'll look through the just 3.
Okay. So in the case of 3, because as you can probably hopefully recognize now, 4 is very similar to 2, right?
Yes.
And it's very similar to the examples I've already given you earlier. So 3 is actually very similar. I mean, it's just, they've only tried to make it slightly trickier with one thing. But the diagram basically looks like this. And so you're told that this is 18 volts, you're told that this is 3 volts, and you're told that this is 6 ohms. You're told that this is R, which is unknown, and you know you want to work out I2. And basically we'll work out everything, but that's the question, right?
Yeah.
Now, if you look at this question, is it series or parallel?
It's parallel.
Right. So really, this should probably be an easier question than question 2. But I imagine what is probably confusing you is this part here.
And 2 cells.
Right? I assume that's what is confusing you.
Yes.
Because otherwise, this is a very simple, you know, this is just like exactly like question 1, right? If it's not for the yellow part, right?
Yeah.
All right. So really, you just need to simplify down the yellow part. Now, these 2 things are batteries, right?
Yes.
Are they in series or parallel?
Power. So they are in series.
Right, they're in series, right? And you really just need to think about it this way. This is, to be clear, right? This is positive and this is negative, right?
Yeah.
So which way is this battery pushing the current? This battery over here is pushing the current which way?
To the negative.
Well, from positive to negative. So this way.
Yeah.
From positive outside the battery to the negative, right? Now this one.
How? But like. But why does it like push towards negative?
That's the way it's defined.
Oh.
Battery pushes current, conventional current, from positive to negative.
Yeah.
Outside the battery. From the positive terminal to the negative terminal.
Yeah.
Now this one, that's positive. That's negative. And so for this one, it's trying to push it this way, right?
Yeah.
Now, who's going to win?
Wait. Oh, so the 18 volts.
Yeah, because it's got more volts, right?
Yeah.
If you've got an 18 volt versus a 3 volt, so the 18 volt will win. And win by how much? What's left?
15 volts.
Yeah. So really, it's essentially asking this question. And it's really saying, I have a 15 volt battery facing this way, right? The result of those 2 batteries is just a 15 volt battery facing this way. Does that make sense?
Yes.
And so this should be fairly simple. So I'll run through this one a bit more quickly now. So It's parallel, so we know the voltage across A and B. Now, because we know the resistance across A, we can then work out the current. Now, B, we don't know its resistance, but we do know the current. So the resistance must equal 15/3, which is 5 ohms. So at this point in time, we know the voltage, resistance, and current for A and B. We could, of course, go ahead and work out their power. Okay, so we've now worked out the V, I, R, and P of A and B, right?
Yeah.
Now to get the current, the easy way to get current 1 is just to add up the currents of A and B, which we have already worked out. So that's how to get that current.
Yeah.
Of course, we could have done it, and we know the voltage is 15 volts. So the resistance we could work out by using 15/5.5, which is going to end up being 30/11. And again, we can then work out the power by V times I, which is 82.5. So this is all for the circuit over here. The circuit has a voltage of 15 overall as a result of these two, counteracting each other. It's got a current of 5.5. It's got a resistance of 30/11 and a power of 82.5. And 82.5 is the sum of these two.
Yeah.
And the current, 2.5 plus 3 is 5.5. The voltage 15 and 15 and 15, it's all consistent. And the resistance, well, let's check that if the resistance is consistent. It should be. So now, imagine I didn't work out the current this way, but I went with working out the resistance, which I could have. So 1 over the resistance of the circuit is 1 over the resistance of A plus 1 over the resistance of B, which is 1/6 plus 1/5.
Yeah.
So 1/6 plus 1/5 is going to be 11/30. So the resistance of the circuit is 30/11, which matches. And once I know the resistance, then of course, everything else would follow through as well. I could have worked out, not knowing the current, current must equal voltage over resistance, which is 30/11 divided by 15 divided by 30/11. So it would have been 15 times 11 divided by 30, giving you an answer of 5.5. And they would all be consistent with each other.
Yeah.
Does that make sense?
Yes.
Good. So those are just examples of some circuit questions. And I've given you quite a few questions that you can sort of work on as well. I've sent them through.
Yeah. So after the lesson, can you please send me the